welcome back to Seek Me channel. Today we will be having a deep down into load balancers. What kind of load balancers does Amazon provide us, and why do we need a load balancer? And what's the role of a load balancer? Do we exactly really need a load balancer to our application or not? And other stuff related like auto scaling the load balancers and how does an auto scaling works and all other stuffs. So once you log into your EC2 instance or your Amazon console, if at all you go to your instances dashboard, there you can find many options like images, elastic block store, network and security, and load balancing. So today we will be looking into load balancing and auto scaling. So if at all you click on load balancers, currently we don't have any load balancers created. So first I'll explain you why we need a load balancer and what exactly its role is. So we majorly use load balancers for handling the traffics and to maintain the availability. So from at any point of the time, if any user is accessing our instance should be ready and available to him at any location. So why do we require a load balancer? Suppose if at all we have a instance running and initially it is getting some around 100 requests which can be handled by the instance. And this 100 requests is, let's say it is for a minute. So by going further, we will be getting a 1,000 requests, which the instance handles, but it's with some latency. Okay, if at all it comes to 10,000 requests, our instance fails because it can't provide a request that much of requests. So in order to avoid these kind of issues, we will be using load balancers. So what do we do in a load balancer? We will be doing something called scaling, that is horizontal scaling and vertical scaling. So what is an horizontal scaling and what is a vertical scaling? So normally in general, horizontal scaling is we will be working on our hardware. That is, we will be upgrading our system. Like if at all we have an instance, currently we have an instance which has 4 CPUs and 8 GB RAM. It will be increased to 8 CPUs and 16 GB RAM so that it can handle the request. So again, the flaws for these things, if at all the request increases or the request decreases, we need to keep on monitoring. So if at all again there comes a new request or a huge request like 1 lakh requests per minute, again we need to change it horizontally. That is, we need to again scale it. And if at all the request goes to 1,000, again we need to scale it down. So this is a not that much preferable option. So we will be going with vertical scale. So I'll just explain you in detail how the horizontal scaling works. So here's an instance which has 4 CPUs and 8 GB RAM, which can handle up to 1,000 requests per minute. So what happens is we are getting 5,000 requests. So what we are doing is we are horizontally scaling it to a new instance which has 8 CPUs and 16 GB RAM. Now this can handle up to say 30,000 requests. So this is good, and now it can handle the requests up to 30,000. But the major problem with this is we need to keep on monitoring this. and we need to change it manually. Why do we need to change it manually? So if at all we are getting some 5,000 requests which can be handled by, sorry, we are getting some 3,000 requests which can be handled by the older instance, but currently we are using a new instance which is costlier than the older one. So we will be paying, ending up paying more than what we are using currently. So again, if it increases, like if suddenly we have a 50,000 requests coming in, again we'll be having another issue, like we need to again manually upgrade our current instance to some other like 12 CPUs and 32 GB RAM. So it has a to and fro issues. So what we'll do is we look into how vertical scaling works. So in the vertical scaling, what we'll do is we'll be having an instance like 4 CPUs, 4 CPUs and 8 GB RAM for handling up to 3,000 requests. So what happens here is if at all we are getting 5,000 requests, what we'll be doing is we'll be creating a new instance with same 4 CPUs and 8 GB of RAM. So what here exactly happens is users request the data to ELB, and ELB, depending on the requests, it will send some to instance 1 and it will send the some users to instance 2. Again it will get the reply and the users get the info which they require. But user is unaware of all the architecture happening at the back. So what this helps is, it helps us in handling the traffic and will be available at all the times. So what if some 10,000 requests arises? The same thing happens, and again a new instance gets created, that is instance two. And the same thing happens in the opposite direction, that is it scales in. So if at all we are getting only 4,000 requests, then it scales from 3 instances to 2 instances, and we are getting only 1,000 requests, then it will come for 1 instance. So this is done automatically. So wherein the concept of auto scaling pops in. So this is where we use auto scaling option. So what does auto scaling means? So we will be setting some particular conditions. Once the instances reaches that particular condition, a new instance gets created, or already existing instance gets deleted automatically. So this is the better approach compared to the horizontal one where we keep on changing the architecture. So if at all we are having a perfect idea, like some X number of people will be visiting your website or your application daily, or your application will be handled by only some particular X number of users, then you can go with horizontal scaling instead of vertical scaling. So if at all you are unaware about the users visiting your website or using your application, you can go with the vertical scaling. So this is how scaling works and load balancer works. So how many kinds of load balancers that Amazon provides us? So Amazon provides us 3 kinds of load balancers. One is classic load balancer, application load balancer, and the other is network load balancer. So these are the three load balancers available for with us. So classic load balancer is the older load balancer, and the newer version is the application load balancer and the network load balancer. So we can go with any of them. If it is your website is a smaller one or a small application, you can go with the classic load balancer. If at all your application is a huge one, you can go with the latest technology, that is application load balancer. So classic load balancer supports CLB is nothing but classic load balancers. It supports HTTP slash HTTP, sorry, HTTPS. In the same way, we have other load balancers also, like application and network load balancers, and application load balancers, that is ALB. Sorry, ALB. This supports WebSockets also. Okay, along with HTTP and HTTPS. So WebSockets are nothing but TCP or TSL. TCP, comma TSL. Sorry, TLS. That is nothing but SSL activation and all those things. So this load balancer, you can apply it for three things. One is for your instance, or one is for your IP, or one is for your Lambda functions. So that is, you can set an logic. So if some 90% of your instance is used, you can set some particular logic, like creating a new instance, or having some new, deleting some existing instances. In the same way, if at all you consider an IP, that is, if some 100 hits or 2000 hits is been happening to your IP, then you can again create a new instance or remove the older instance. In the same way, you can also look for the lambda functions. If some number of clicks or number of hits are being done for the lambda functions, you can create a new instance, or you can do whatever you wanted, like create a new lambda function or delete an old existing one, like this. So let's see how it works in the hands-on. So if at all you log in, so currently we haven't created any load balances, so it's empty. So let's go and create a load balancer. So if at all you see, as I said, there are three load balancers. One is the classic one, and the application and the network load balancers. So classic load is a previous generation one, where it supports HTTP, HTTPS, and TCP. Whereas application load balancer, you can use it for accessing your website or instances from using HTTP or HTTPS. That is, you can even create an SSL certification and get it verified. That is your application or a website. So first, let's create it with classic load balancer. So once you click on create load balancer, first you need to name your load balancer. So you can name it anything. So I will be naming it, since it is a classic load balancer, CLB. Okay, so the inbound rules, or you can access it from HTTP, and you can even access it using HTTPS also. Okay, so whatever may be the calls made from HTTP or HTTPS by the user, internally the load balancer talks to the instance using HTTP only. Okay, next is the security groups. So you can create a new security group, or you can use an already existing one. So I'll be using an existing one. Okay, next is the configuration. So if at all you wanted to have a certificate, you can do it. So since we don't have any certificate, so what we'll do is we'll just remove this HTTP. So in some other video, I'll be showing you on how to activate the HTTPS and how to attach your certificate so that you can verify your website. So again, next configuration, since we have removed the HTTPS, this page is blank. Next, go to security health check. So this is the health check where the ELB pings your instance. So the request is made through HTTP and the path is /index.html. If at all your application is in PHP, you can change it to index.php. or if at all you don't know your application what it is, or what technology it is running on, just have a slash. So it will directly go to the IP or the website URL. Okay, some abc.com. And the response timeout is 5 seconds, and the interval is 30 seconds. So for every 30 seconds, there is a check done. Okay, so unhealthy threshold is 2. So that is, for every 2 unhealthy checks, you will get a trigger happening. So if at all you go for EC2, so you can add, if at all you see that instance that is already available with us is has been added to the list. Next is the tags. So if at all you wanted to handle any tags, since you will be having multiple clients or multiple instances running, you can have your own tags here and go for review and create. Once you click on create, your load balancer gets created. And one more thing is, if at all you are using a free tier of Amazon Web Services, you will be able to create only one load balancer. So if at all you create more than one load balancer, you will be get charged depending on the usage and how much time you are keeping it live. So once you click on close, yeah, this is your first load balancer. That is the general classic load balancer that we have created. So if at all you check here, instances, go for instance. So where you can see like out of service, so it will be changed to in service. So it takes some time, and the availability zone is, sorry, and your availability zone is AP South 1A. So you can have your multiple availability zones depending on your location. And this is the health check that is done. Listener, that is inbound is from HTTP, and this is the monitoring. If at all you keep this, you will get your cloud watch, how much requests are done, how many HTTP requests you are getting, how many latencies it is happening, and everything. Tags, if you want, you can add it whenever you wanted it. Migration, this is not needed currently. So this is for the latest versions. So if at all you go for the instance, you can see that the status has been changed to in service. So if at all you go for a description and copy this DNS. Okay, just copy it. Yeah, copy and open it in a new tab. So you see, you are in redirect. I mean, like, it's not that you are redirected to your instance, but it is fetching the data from your instance and displaying it here. So whenever a traffic comes, it will just directly comes to the load balancer, and then it goes to the instance. So this is how a classic load balancer happens. So in the same way, you can create a application and network. So let me just close this, delete this, and I'll be creating an application load balancer. The same pattern, now here you need to give the name. So since it's an application load balancer, I'll give it as ALB, and your IP address is IPv4. You can change it to dual stack also if needed. Again, the same load balancer is only HTTP. We are not going to select HTTPS currently. And then the zones is, I will select all the zones. So here the subnet addresses, that is the IPv4 address is provided by the Amazon itself. If at all you are having any static IPs or you have purchased any static IPs, you can mention it here. Next is the security groups. Same, select the existing one. Then configure routing. Same thing. So here you need to create a new group. So if at all I have already created a group. So if at all you go here, there is nothing but you will be adding your instance so that you will be creating a new group so that in future, if at all you are creating any multiple load balances and you want all those load balances under a particular group, you can do this. So if at all you see you have a target type, as I mentioned you earlier, you can target your instance or you can target through IP or you can target with your Lambda function. So currently I will be doing it with my instances. Okay, so this is your advanced health check. So it will be the same. Threshold is 5 seconds and unhealthy is for 2 seconds. Time interval is for 5 seconds. So you need to register your target. So I have already added the instance in my group. So what I'll do is I'll go back and show you how to create a group. So I'll just create a new group, name, mm, application load balancer group. So you see these are all, you can define a traffic port override and all those things. So next register your target. So this is your available instance. You click on add register. Now review. If at all you see this is your name, scheme, listener that is port 80 through HTTP and routing security groups already selected one. This is an instance which we have added and click on create. Now the same thing. Once you close, you need to wait till your status becomes inactive. Sorry, status becomes active. So you will need, it takes sometimes 5 to 10 minutes. Then you can wait. So just to confirm, just refresh your page. So it's still in provisioning. Once it is changed to inactive, we need to copy this DNS and then open it in a new tab. So again, you will be seeing the same thing. So if at all, if you open this, you will get an error since we have already deleted the load balancer. You see, if at all it's still loading, it's unable to connect to the instance. You see, you have got this error. Once it is still provisioning. So if you refresh the page, so it should be changed to active. Yeah, so once it is active, again just copy this, open it in a new tab. So you can see the same page. That is again, this is getting the output from the same application. So the same thing happens with the network, but with the network you can't access it from the outside. You can have a particular assignment out to that and then you can access it. So again, I'll be deleting this, not now, but once I have shown you how this auto scaling also happens. So if you can see launch configurations, I'll just delete this. Let's delete. Okay, this is an auto scaling group. So I'll create a new group. So this is the latest dashboard. So if you click on create auto scaling group, you can name one. So this is my first auto scaling group. So first auto scaling application load balancer. This is for application load balancer. So there are no templates. So I need to create a new template. So the new template is nothing but again I need to create my own instance. So first template. Okay, again you need to say AMI required. So again you can select your AMIs. That is, you can select it, go with anything, but I'll go with Ubuntu server that is the same of the current instance. So when you select, you can select the other like higher instances or the lower instances, but having the same instance is a good one because some applications might not support the platform. So if at all you want, you can select like 8 virtual CPUs or 16 or 2, anything. So just say if at all I wanted this, so it will be changed to 16 GB and 8 virtual CPUs. Key pair is already I have one, so you can give that. So this will be virtual private cloud. So this is the general one. So that is 8 GB. If at all you wanted, you can add a new volume or change this to 30. And this is a hard disk that you're adding. And if you wanted to add any tags, you can add it. And you also have an additional details like spot instances. You can create a new IAM profile. Termination protection, I mean, like you can even ask them not to remove the instance which was created and monitoring it. If at all you enable, then this auto scaling will be monitored and you can watch it now and then. Then create launch template. That is finished. Now go here, refresh. You'll see your template here. Okay, and then click on next. Subnets, you need to select the subnets. You can select one or you can select all of the subnets. So these are your availability zones. So since my instance is in Mumbai, inside Mumbai I have three availability zones. That is 1A, 1B, 1C. And click on next. Yes, see. Since I have selected a new one and it's a free tier, it is not supported. So I need to go here and then view launch template, change it. Reload. Give your name. Select your template. Next. Subnets. Select your subnets. Next. So you can just go here and modify your launch instances. Yeah, for instance, type is A2 large. So what I'll do is go for launch template, delete this one. Create a new template. So if you want, you can select your key pair, that is C-E. Storage volumes, everything will be the same. Instance type, I'll leave it to default. AMS, I'll leave it to default. So it will be the same one. Same, go to the advanced and then click select enable the CloudWatch. Launch templates. Here, refresh, go to your previous page, select your template. So here you can have the on-demand instances. That is, you can have started with one or two instances. So if your usage is more than 70%, then you can create an instance, and if it is less than 30, it will get deleted. Mhm. So you see for micro, ting, 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 T2 micro. You can select the flexible size, or you can select the same one. So again, it depends. Subnets, select the subnets. Next. So your health check is 300 seconds. So you can have it. This is an optional enable load balancing. So if you have you can go with the same target group, or you can have a classic load balancer also. Click on next. So this is a designed capacity. That is, if at all we wanted to start with two instances and maximum is one, minimum is two. So if at all you wanted to choose a different one, you can do it. Otherwise, click on none. So it will be the default one. So click on next. If you want any notifications, you can have get it added here. Next. If you want to add any tags, you can add it here. You can add up to 50 tags. Next. So this is a load balancing, this is availability zones, create auto scaling group. So we have already created an auto scaling group. So if at all you go here, click on activity, and you will be having automated scaling, instance management. CC. We have two instances that are pending life cycle. So once I go to this and reload it, this will be changed again. You see, if at all you see here, instances, you have activity history, in service, go to instance management, it is still pending, life cycle, so it will get active. You see, one is in service and one is in pending. So if at all you wanted to check whether it is working or not, copy this and go to any DNS checker website, load your instance there, search. You see, you are given with two IPs. So which means is your application gets switched between, I mean your request to the application gets switched between these two IPs. So you see 126 and 127. So if I go here and search for the activity, you see one is successful and one is under still process. This is the instances. Okay, so depending on your requests and the inputs, the instances gets added and created. You see, if at all you see here, one is created in 1A availability zone and one is created in 1B availability zone. And health status is healthy for both of them. So until and unless one of these gets exhausted, the new one is not used until then. So the same data is created. Reload, 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 reload. You will see this. You will see the same thing, but if at all you wanted to see it here, you can see it exactly. So this is how auto scaling works and how load balancers are used in AWS. So if you have any queries, just drop down in comments and I'll get back to it.